All right, so our math magicians, on this great day, we're going to teach you a new language, a whole new world, and we're going to find and compare measures of angles. First off, you need to spell correctly. An angle is not an angel, okay? Do not say angel like this. Both of them are divine, I'll give you that. An angle is a beautiful thing. An angel is a beautiful thing, okay? But an angle tends to be a little bit more useful to us than angels right now, okay? All right, so first off, what is an angle? Sometimes it's easier just to see an example of what it looks like. An angle is a ray and a ray. So it's two rays that share the endpoint. Two rays that share endpoints. So they can be, however, they can be opened very tight, or they can be opened very open. We also need to make note of certain things here. Each ray is called a side. Each ray is called a side. So when we talk about the sides of the angle, I mean the ray. So in this context, if this is A here in what I call the corner for now, this is B and this is C, then my sides are going to be rays. So side AB, and I'm going to write it as a ray, and side AC, and I'm going to write it as a ray. So those are my sides. Now the A has a very special name. Starts with a V. Vertex. Vertex. So what's the vertex of this angle? Simply A. It's a point. It's a location. Some people say corner, but we will always say vertex. By the way, the plural of vertex is vertices. So a non-example here of an angle this would not be an angle right here because they're not actually touching, okay, as a single angle. The question is this a non-example? And technically, it is still an angle because they do meet, even though there are endpoints there as well. So by official definition, angles go on forever. However, sometimes we're just talking about a part of the angle, which we still call an angle. Okay. So anytime you could argue when lines intersect, when rays intersect, when segments intersect, any of those will always form some sort of an angle. All right, a right angle whose measure is 90 degrees. And we always write that like this. We can always draw it with a box in the corner. Yes. The non-example over here is we just don't have enough information. It might be 90, it might be 91, we don't know. So this one is just not enough information. Yes, Abby. Like this, where the angle is less than 90 degrees, and this is the less than symbol, not the angle symbol. Obtuse would be greater than 90, but technically, it's not just greater than 90. So we have to put another limit on it. And what would that? So I'm going to clarify this by not writing it like this, but I'm going to say like this, that it's going to be between 90 degrees. So, and I'm going to say X for my variable, 180. So it's between those two there. Yeah. So if you're explaining acute to your brother, your little brother, you'd say, oh, it's got to be less than this upright, less than 90. Good, but technically, yes, it's got to be greater than 0 as well. Good thinking on that. And X in this case is just saying the angle measure. All right, and a straight angle is exactly equal to 180 degrees, a straight angle. Now, a line is a straight angle. So that one is used not as much. So just real quick, an acute angle could look something like this. An obtuse angle can look something like this. And a straight angle officially is just a line like this. Now, I am going to put vertices here. Each of these has a vertex. And technically, this one has a vertex as well. So be sure to note that this angle at C right here would be a straight angle. At C, it's a straight angle. So let's go ahead and name these angles. So this one, his name is Hafiz. Hello, Hafiz. How are you doing? Oh, I am doing so very well. Thank you. Just kidding, his name's not really Hafiz. Here's how we can name them, okay? 3, 4, 5 different ways to name, so eyes on deck as we follow along. I'm going to throw some, whoa, time out. So let's walk through how one would name this. You definitely need letters or numbers in order to do a name for this, okay? So for example, if we have the letters A, B, and C on these points, and you can arbitrarily put these points there, B does have to be in the vertex in my example. And you could have C, it doesn't matter. Whatever letters you've chosen, if it's different, that's fine. All right, so this is how you name the angle. Number 1, this angle has a name called angle ABC. There's one name for it. Here's another name for it. Angle CBA. Here's a third name for it. Angle B. And here's a fourth name for it. I put a number inside, and it's simply called angle 1. Good, so an observation we make is if B is the vertex, that's the major definition of its name. That's where that's the biggest thing that defines it. So it starts at A, hits B and bounces, goes to C. That's what this one says. This one says starts at C, hits B and bounces to A, CBA. Or we're just talking about the only angle that's at B. The only angle that's at B. Notice we're not talking about this exterior angle. We're only talking about this small one inside. Now notice also that we have a number 1 here, as opposed to having another number with a symbol. This right here is the measure. That's how big it is. And it has to have the degree symbol. So this angle, this is the name, angle 1, or angle B, whichever name you choose. Sometimes it's easier to say angle 1, sometimes it's easier to say angle B. And this is its measure, and we know it's the measure because it has a degree symbol there. No degree symbol, it has to be the name. Okay, so let's complicate it, and notice that we've got more than one angle hanging around here. In fact, how many angles do we have? We indeed do have 3, so let's see which angles they are. So I'm going to arbitrarily put some points out here so that we can see some names. I'm calling this one B, this one A, C here, and D down below. Notice the angles we have. We have this medium-size angle here. We have this itty-bitty angle here. And we have the larger angle that is the sum of the 2 angles. And if you wanted to argue, you could say, but Swenson, we've got angles around the outside. Yeah, but we usually don't talk about those ones. So we have 3 angles on the interior there. All right, so how do we name these ones? Well, this first one right here, that's kind of hanging out within this region of the blue that I marked, is called angle BAC. Notice I start at B, I bounce off A, and go towards C. So it's just inside that blue. That's the stuff we're talking about. We could also reverse the letters, and we could call it angle CAB. Starting here, bounce off A, going to B. All right, another one here. This itty-bitty angle inside there, that has the angle name of angle CAD. Starts at C, bounces off A as a vertex, and goes through D. Again, you can flip that to call it angle DAC. Now, if I were talking about the entire angle here, and we can label it like that sometimes if you're talking about the whole thing. Sometimes you'll see that written with a 47 degrees right here. When you see that, it means that the large angle has the measure of 47 degrees. Not the blue one, not the red one, but the entire angle. All right, so that black one that I labeled is called angle BAD. More than one angle in a particular vertex that meet at the vertex, you're not going to use simply angle A, because we could be blue, red, or the black. Now, we could also throw some numbers in there. It is just as feasible and faster, actually, to throw numbers in there. Angle 1, angle 2. So much faster, actually, to use numbers. Because notice I'm not forced to write 3 letters. I can just write one number right there. So the BAC, angle BAC, is also called angle 1. And I'm going to put an arrow there, not an equal sign, because technically it's not an equal sign. And CAD, you could say, is called angle 2. Now, a lot of diagrams will not have the 1s, the 2s, and 3s written in. But if you choose to write the 1s, 2s, and 3s in there, that probably will speed up the process for you. The question is, am I unable to name the angle BAD using a number? Right. You can, if I had, like we did earlier, drew this little arc here, and instead of having the degree there, I said 3, then it would imply that all across there. You can do that. The problem is the arc is used in a different context, can mean congruent, which we'll get to later today.